introduction to gas laws. So we're going to start first with the kinetic molecular theory. The kinetic molecular theory is a theory that explains the physical properties of gases by describing the behavior of subatomic particles. Kinetic means energy, or movement, motion. All gases have mass. Gases are easily compressed. Compressed means that we can move particles closer together. Gases completely fill their containers. They diffuse rapidly, which means that they can spread out very quickly. And gases exert pressure. The kinetic molecular theory has 5 different parts. The first part is that a gas consists of very small particles that have mass. And you'll refer to these as atoms if there's a single atom, or different molecules. An example of an atom that's a gas would be argon, or if it's a molecule, carbon dioxide. Number 2 is that gas particles are very far apart from each other, which is why they're easily compressed. Gas particles are in continuous, rapid, random motion, so they're always moving. The collisions of gas particles, both with each other and with the container, are perfectly elastic. This means that no energy is being lost. And the average kinetic energy of the gas particle depends on the temperature of the gas. You can predict the behavior of gases based on the following properties. Number 1 is pressure. Number 2 is volume. Number 3 is the amount. And number 4 is the temperature. So we're going to look first at pressure. Pressure is defined as the force that a gas exerts on a given area of the container in which it's contained. The SI unit for pressure is the Pascal, symbolized with the PA. If you've ever inflated a tire, you've probably made a pressure measurement. Usually they're referred to as PSI, or pounds, which is the force, per square inch, which would be your area. There are other units of pressure that we will be using within this unit. One of the most common ones is atmosphere, symbolized with an ATM. We have kilopascal, which is just another version of the Pascal unit, with a kPa. Millimeters of mercury, which is symbolized mmHg. We have torr, and we have pounds per square inch. You will see it as PSI or lb/inch squared, just depending on the particular problem. There are equivalences between each of these units of pressure. 1 atmosphere is equivalent to 101.3 kilopascals, which is also equivalent to 760 millimeters of mercury, which is equal to 760 torr, which is equal to 14.7 psi. We're going to be doing some pressure conversions, going back and forth between some of these units. So these equivalences are going to be extremely important for us. All right, the second property is the volume. The volume is the 3-dimensional space inside the container holding the gas. The SI unit for volume is the cubic meter. A more common and convenient unit that we will be using is the liter, or forms of the liter. Think of a liter of cola to get an idea of how big a liter is, for any of you who've seen Superbad. The amount of the substance is a little tricky, so within this unit we're going to be using moles when we do talk about the amount of the substance. You'll see it referred to as the letter N in this particular circumstance. A more common and convenient unit is the molar mass of the gas. So you'll see mole or molar mass. Because by definition, Avogadro's number, 6.02 times 10 to the 23rd particles, is equal to 1 of these cute little guys. No. Is a mole, which is why we use mass in moles. So we don't have to deal with this giant number. Temperature. temperature is the measurement with which you're probably the most familiar with. You've been hearing about it since you were a young student or a young kid. It's the measurement with which you're probably going to understand the best, but it's really complex. So it's the average kinetic energy of a substance. And as I said before, kinetic just means motion. For this unit, we're going to be using the temperature scale for Kelvin. It starts at absolute zero, which means that there's no molecular motion. There's no movement at all at this particular temperature, which is equivalent to negative 273 degrees Celsius. We have some conversions that we will be doing to get us either from Kelvin to Celsius or from Celsius to Kelvin. So if you want your units to be in Kelvin, you're going to add 273 to your Celsius unit. If you want it in Celsius, you'll take your Kelvin temperature and you'll subtract 273. Within this unit as well, we will be referring to STP, or standard temperature and pressure. This just means that we are at a temperature of 0 degrees Celsius, or it would be 273 Kelvin, and we're at a pressure of 1 atmosphere. I know STP does not